Let's talk about the three objectives for the slope of a line. First, we're going to find the slope of a line through two given points. Then we're going to graph a line and its slope. Graph a line given its slope and a point. And then third, we're going to take a look at standard form and its slope in standard form. Now, section 3.4 talks more about like slope-intercept form, y equals mx plus b, or point-slope form, y minus y1 equals m parentheses x minus x1. So that's not the stuff we're doing today. We're going to do that with 3.4. Today we're looking at the general form, which is called our standard form, which is primarily ax plus by equals c. Okay, and it's kind of intriguing because I remember in high school, I didn't really learn this method. My teacher didn't go through this, but this is actually very important to go through, and we'll talk about it today, how it is. Okay, the different relationships that show up. Take a look first. The slope of a line. The slope of a line. What have you heard the slope of a line defined as before? Many of you have heard this term or heard this definition.
Last year I did this, and my teacher made us repeat like all of the formulas every single morning. So it was like slope equals rise over run, or y2 minus y1, or x2 minus x1.
Very good. And those are the two general representations you see for slope. The other representation is to use delta symbols, and we'll take a look at that today, how deltas are used. Okay. The idea, again, is that we are looking at how much an actual line changes as a function of its location along the x-axis. So if I had, say this is like well, in this case, I'm going to go in the next example. Say this is like a skateboard ramp, right? You would say that it has a certain slope. But if I drew another ramp on top of it like this, what would you say? That second ramp is what compared to the first ramp? The blue ramp is steeper than the original one. So slope is really a measurement of steepness. That's what it is. Now, steepness is also thought of as like an incline. If you're walking down the street, what's the slope of the floor right now? There's no slope at all. It's zero, right? Slope is zero. I'm not moving up or down. Technically, I probably am, right? We all know that. Obviously, it's probably not perfectly flat, but it's pretty darn close. How can you tell? Take a cylindrical object, put it on the ground. Take a cylindrical object, turn it 90 degrees, put it on the ground. You can see that it's not moving on its own, so there's really almost no gradient to the floor. It's a very simple way. Just put a marble on the ground. See which way it rolls. Gravity automatically pulls it toward the downward direction. If it rolled to that corner, it would mean that the whole floor was sloping to that corner. I live in an old apartment complex, which has floors that are like really warped, like crazy warped. Where at the joists here, the junctions, it all slopes down. Okay, but in a modern building, things should be pretty flat. So our slope is our steepness, or our incline, right? Now, the other thing a slope is, and this is a little bit outside the box thought, but it is something else. It's what's called a rate of change, really. And you've heard the term rate of change with distance rate problems. So the rate in the problem is actually a slope. So I'm running, okay? I'm running down the block, and I'm running at like, say, 3 miles an hour. Pretty slow, actually. Let's say 6 miles an hour. So I'm running 6 miles an hour. It's like a 10-minute mile. That's your slope, believe it or not. That's the slope at which you're changing your position. So every hour you move 6 miles. So the slope would be 6 miles an hour. So if I were to show what that looked like on a graph, let's say here's distance covered. Whoa, why did that just happen? If we take a look at a distance versus time graph, and we say for this example, here's distance along the y-axis and time is along the x. As we progress, what we'll notice is that our distance increases like this, right? Here's our increase in distance. We start at the origin, or the starting line, and over time, we move further and further away. Well, this would say like, all right, you know what, maybe this is, say, 5 mile marker, okay? Everything upside down. It's a 5 mile marker, and we'll say here the time is 1 hour. If you can run 5 miles in 1 hour, what's your hourly rate? If you run 5 miles in 1 hour, 5 miles in 1 hour, what's your hourly or your mile rate, whatever it's called?
5 miles an hour.
5 miles, but what's your minute rate? Sorry.
Oh.
How would you find out how many minutes per mile?
You divide 1 hour into 60 minutes by 5, so it's 12 minutes.
So it'd be 12 minutes miles, right? You see how you're dividing there? That's the idea of our rate. So here you would say 5 miles per hour would be like your slope in this case. When you look at your slope, you're going up 5 miles every hour. But the idea of a rate is the exact same thing as a slope. So it's a change. If you had, say, some sort of an investment in a bank, and it was 5% annual that you made on interest. That's a rate. That's a slope. That's really what it is. So whenever you hear of any rates at all, it's a slope. Ever get in a cab? What does it say on the outside of the cab? What's the advertisement on the outside usually?
Flat fares like $2.50.
And then what does it say afterward? For every what?
Like tenth of a mile, it's like
Yeah.
cents.
Exactly. It's a rate. It's a slope. Every tenth of a mile, it's $1. Every whatever it is, whatever the rate is for that going rate. I don't even know what they are these days, okay? But say that's a rate again. In DC, when you take the subway, in Boston, anywhere else besides New York, really. New York is a flat rate, right? We all know that for subways, it's a flat rate. You can go from the bottom of the 4 line all the way up to the top of the ACE. It doesn't matter where you are. It's a flat rate as long as you get on and get off. Other subway systems is not. Anybody know how other subway systems work? What do they have for other ones?
Well, I know like the one in Baltimore is different. It depends on how far you go.
It depends on how far you go, so it's a function of your distance traveled, right? So again, the one in Baltimore is a function of the distance traveled. This is really pissing me off. I'm sorry. I'm trying to shut this off. What happened?
You have to like read the
I'm trying to. Apple TV still working. Did it go up?
It says 6.
Oh no, this is so funny. What do you say?
Guys, go to the next slide. Okay. So for this one here, we're going to say, let's pick 2 points. Does not matter where. Put a point here, put a point here. Okay, give them coordinates. And again, it does not matter at all. I'm going to say this coordinate, but it has to make sense, the coordinate. Let's say this one is 7, 4, and this one would be then, let's say, 13, 4. They clearly both have to have the same y value because they're at the same height. But the x value, you could pick whatever you'd like it to be. It doesn't matter. Okay, so I call this happens to be 7, and I say this happens to be 13 for the x. They're both at a height of 4. If you were to find the slope between those 2 points, all you would do is use your formula, rise over run. Okay, well, here's rise over run. What's the rise between those 2 points? How far up does it go?
0.
It doesn't go up at all. Yeah, it's 0. And you can tell because in our formula that we talk about, it's just 4 minus 4. That's what the change in y is. Look at your y coordinates. 4 minus 4. That's just 0. What about the x coordinates? What's the change? 13 minus 7? 6. Okay, that's where it comes from. So, and you don't need to write this really if you can see it from the graph. So what's your slope going to be? 0 over 6, which is just, everybody? 0. 0 over anything is 0. So whenever you have a horizontal line, the y values happen to be the same, which causes your numerator to be 4 minus 4, or whatever that number is minus whatever that number is, the same number, a minus a, which is still 0. So whenever it's a horizontal line, the slope is indeed 0. It's undefined, that's what it says up here, but we'll also talk about, that's all right. we'll talk about what that actually means a little bit more algebraically, or I guess theoretically. Okay? So let's take a look at the vertical line part now. So the vertical line we're going to notice is just the opposite in a sense. We're going to have the 0 in the denominator, but let's pick 2 points on this one now. Let's say this point up here is 15, comma 7. And this point right here is 15, comma 5. Alright? Clearly the x coordinates are the same because I go over 15 and then up 7. I go over 15 and then up 5. So the x's must be the same here. So the run in this case would be 0. Let's take a look at it. We know that our formula is delta y, and notice I'm using different representations. I'm doing this on purpose. So you can think of it as rise over run or deltas. The change in y is going to be 7 minus 5. Look at your y coordinates. 7 minus 5. The change in x is 15 minus 15, which is 0. So you're going to get 2 over 0. Now, we talked about how you can't divide by 0, right? That's the whole idea. You cannot divide by 0. It's undefined. That is true. Absolutely. But theoretically speaking, the definition of dividing by 0 is considered to be what's called an infinite limit. And here's what I'm talking about. I'll explain in a moment. Look at my arm, okay? And I'm going to use it like a little bit of like a, what's this called? Like an analog dial, okay? Analog dial. Right now, what's the slope of my arm? 0. What am I doing to the slope? Okay, so give me a number. 5, 3, 4, 6, 7, 8, 9, 10. What's that? Because the steepness is increasing, right?
Yeah.
All right, cool. I agree, absolutely. But now I get up to here, and I'm going to close the vertical. Now the slope's like 10,000, 20,000, 100,000, 2 million, 5 million. What's happening to the slope? It keeps increasing until I get out to this side. Then the slope is what? Because the slope would be not positive, but negative. So there's something in between, and we just kind of ignore it, right? That's kind of what we've been doing, and you've been told like it's undefined. It's not really undefined. It's called an infinite slope, really. Because think about it. If I wanted to walk up a hill, and the hill had some incline, I would walk, eventually I would make it to the top of the hill. Agreed? If there was some sort of an incline? Even if this hill kept going, I would eventually get there. But if there was a vertical wall, and the wall went on forever, and you climbed it, are you ever going to get there? You're just going to keep climbing up and up. You're not going to make any sort of transcendence in a horizontal direction. So if there's any slope at all, and I'm walking up that hill, I'm still moving forward. I'm still actually moving in some direction in the x. But the minute I try to climb a wall, I'm not changing my x value at all. So I'm climbing at some infinite slope. That's what's happening here, really. So a vertical line, the slope is undefined. You should know that. But you could say that the limit of the slope is infinite. And you'll hear more about limits in pre-calc and calculus, but you could just jot that down as like a side note if you like. All right? So the limit of the slope of a vertical line is indeed infinite. Something good to know, and your teachers will be a little bit impressed later when you say that. You might not know exactly how to prove that algebraically just yet, but the idea of what I just taught you there, how the slope is 0, and then it's like a half, 1, 2, 3, 4, 5, until you get up to this big, big number, but then once you pass that number, it's negative suddenly. How could you go from a really large positive number, and then suddenly the slope becomes a really large negative number? There's got to be something in between. It's actually infinite. That's what that is. Okay? Infinite. All right, on the right-hand side, we just discussed positive and negative slope. Again, positive slope is an increasing line. We look at the line from left to right. This line is indeed increasing. So it's a positive slope. This line is decreasing. This is a negative slope. Please write that down, that positive slopes are increasing lines, and negative slopes are decreasing lines. These terminologies that I'm going through here are really important. Okay, you're going to use these terms in your future classes, so you should know them. So a line with a positive slope is increasing, a line with a negative slope is decreasing. Please take a look at example 1. Try part A. If you get it, go on to B and C. You can feel free to check your answer with me if you would like. Okay, but try part A on your own at least for now. And there's not just one way to do this. There's only one answer for part A, but there are 2 ways to do it actually. two ways, depending on which order you pick your coordinates to be. Just be consistent, please. Consistent. I'm going to put up both possible ways on the board so you can see what I mean. So I'm going to do part A in two methods. Okay, pick one or the other. Your answer should fall in one of those categories. It does not matter, because you get the same answer. So if you start by doing 5 minus negative 2, then you need to start by, for the x, doing negative 3 minus 4. But if you do negative 2 minus 5 and go that way, then you need to do 4 minus negative 3. But be consistent in the order in which you subtract the x and the y coordinates. So if you're going to call the second coordinate y2 and x2, then you have to call the first coordinate y1 and x1. But it doesn't matter as long as you're consistent. Let me show you. This becomes 7 over negative 7, which is indeed negative 1. This becomes negative 7 over 7, which is also negative 1. So it does not matter which way you subtract as long as you are consistent. So if you're going to start with the second coordinate and subtract the first coordinate, you have to do the same thing for the denominator. Start with the second coordinate and subtract the first coordinate. If you're going to start with the first coordinate and subtract the second coordinate, then start with the first coordinate and subtract the second coordinate for x. But either way is fine. Either way is fine. What you really have to be careful of is that you start by saying, like, you can't do 5 minus negative 2 and then 4 minus 3. Oh, sorry, 4 minus negative 3. Okay, you can't mix up the order. So if you're going to subtract the first coordinate of the y minus the second one, you need to do the first coordinate of the x minus the second one, or vice versa. But you cannot mix up the order in which you're subtracting. Okay? So choose either method A or method 1 or method 2 for this. Either way, you'll get negative 1 as your answer there. Questions on part A? On part A? Please ask, because we're going to keep doing slope. So if you get stuck along the way, I can explain a little further. If I don't hear any questions, I'm going to assume that we're good on this for now. Okay, go on to part B, please. And by the way, when I do it, I just use the first one minus the second one always. It doesn't matter at all. Whatever I see first. So I do 4 minus 6 first. But it makes no difference at all. And then I'll do negative 1 minus 5. If you did it the other way, you would get positive 2 over positive 6, which is still indeed 1/3. Okay, which is still 1/3. Check your answer for part B, please. Make sure that makes sense. Okay, and then part C, anybody know what it is just by looking? Just by looking?
Undefined.
Why?
Because, I just saw that.
Okay, just by looking, why? You're right.
Oh, well, because both the x are under 2, so.
Yeah. When the x's are ever the same of 2 points, that's going to be a delta x of 0. And since it's delta y over delta x by definition, remember this is our definition of slope right here. Since delta x is 0, because it's 2 minus 2, this has got to be 0, so it's undefined. Okay, it does not matter what the top is. It does not matter what the top is. Okay, this is some number, I don't care what it is, over 0, which we could say, God bless you, is undefined for slope. Okay? Some books, and your book does this, so be careful. They also use the term no slope. Now, I would never use that because it's confused with 0 slope versus undefined. So please don't use the word no slope. Either say its slope is 0 or the slope is undefined. You see what I'm saying? The book says that an undefined line has no slope. But to me, if I had no money, how many dollars do I have? So no money is $0. So no slope to me means 0 slope. But the book says no slope to them is an undefined slope. So just don't use the term no slope. Just say either the slope is 0 for horizontal lines or the slope is undefined for vertical lines. Okay, but do not say no slope because it's just ambiguous. All right, the next view is this. I want you to write down, you have the theorem now. I want you to read through the theorem. I'm not going to go through the proof for the sake of time. I did, though, I went through all the proof work in my video. So if you want to see and you want to add to the slide, there's maybe 5 or 6 lines of writing down for this proof. You can go through that and you can copy it down, but I'm going to leave that for you to do on your own. Okay, it's another 3 or 4 minutes on the video if you would like. But what I really would like to talk about is the actual theorem. So can I get someone to read this for us nice and loud? Or
The slope of a line in the standard form ax plus by equals c, when b is non-equal-0, is equal to negative a over b.
is equal to negative a over b. That's what the slope actually is. And there is, again, this is the proof to show how it works, but I'm not going to go through all of this. But the idea is that if you have something in this standard form, like 5x plus 7y equals 12, you could just take negative a over b, and that's your slope. Okay? I think you should all desire to know where this comes from, so please watch about 2 minutes of the video to see the proof for it. Okay? Let's go on to the next slide. Let's take a look at this example, which is indeed in standard form. Okay, this is in standard form. ax plus by equals c. So go ahead and just find your slope. Use the definition we just said. Slope is negative a over b. So what's the slope in this problem? What's a? What is a, people? 2. And what is b? 3. So we have negative a over b. That's our slope for this line. We're not even going through any of the work. I know a lot of you know how to solve for y and put it in standard form. And if you want to practice that, you can. But you'll end up getting, you'll get y equals negative 2/3 x plus some y-intercept. And if you remember, slope-intercept form is y equals mx plus b. We haven't talked about it yet in here, but I know a lot of you saw it. So if you solve for y in this problem, you'll get negative 2/3 as a coefficient of x, also proving that this is negative a over b. So you could check that to see if you would like to. Okay, you're welcome to do that. Remember, if you're ever going to graph on a calculator, that has to be in y equals form. It's got to be in y equals form. So you should be able to solve for y anyway, which I know a lot of you know how to do. You know how to do already. Okay. So standard form, if you ever given a line in standard form, don't recalculate everything. Just use negative a over b. Okay, it's a simple way to remember. Okay, negative a over b. Just use that every time. All right, example 3. I want you to read through this and take a minute to think about it. Take a minute to think about example 3 here, please. Okay, think about the 3 different options here. Or the 3 different parts. And a lot of you will be able to do part A very easily. Very easily. So I hope you can maybe try and look at part A and see if you can do that one. Part B is a little tougher. Part C is the most tough, or most difficult. Think about what slope means and what a line actually means. This is more difficult. Whereas the first one is obvious, right? So can I get somebody for the first part, part A, to discuss and explain their answer? And I know it's not easy right away, but discuss what they think. Summer, go ahead for part A. You got negative 2. What do you mean you got negative 2? For the? Okay, why?
Because slope is y over 1, which is y over x, and the y coordinates are changing, like each coordinate is like a negative 2, minus 2 from each other, and x is just plus 1, so then I put the y over 0.
Yeah, very good. And that's obvious in the first one. I know this is difficult at first, or difficult to wrap your mind around. You don't actually need to even come up with the equation of the line at all. Just to find the slope. Remember, a line can only exist if the slope is constant. For example, here's a slope of like 4/3. But what if I were to have something on a graph that looked like this? Instead of just a line, I had something like this on the graph. That curve, which you'll know is like a parabola, does not have a consistent slope. The slope is negative, then the slope is 0, then the slope is positive. It changes throughout. But a line has a consistent slope. So that's, in essence, what we're looking for. We're looking for a consistent slope in this problem. Okay, so for this first one, a lot of you notice right away that, yeah, the delta y between all of these coordinates is -2. The delta x between all of these coordinates is +1. So delta y over delta x is really -2/1, or simply -2 for the first one for slope. Okay, very good, Summer. That was the, I'd say easier one because it was obvious. How about part B? Part B.
What is not, it is not a line.
Why?
Well, because it starts at one number and then it goes down, but then it goes up again.
So we know that it's got to have some negative and then some positive, right? So it's decreasing and then it's increasing, which makes no sense, right? Let's take a look. This goes up 2, then it goes up 4, then it goes up 2. So at first it's like, oh, that's kind of weird. Those changes are weird, but maybe the y will change as well accordingly. But this goes down 3, then up 3, then up 3. So clearly we can see that there's no consistent change here as this value changes. And if I were to graph this, believe it or not, just to get a visual, look like this. That's what it would look like. And that's what Wirth was talking about. Wirth said, well, it goes down first, it decreases, then it increases. Anybody know what function that is, believe it or not? Not quadratic is close, but quadratic is a curve. It's curved. This is an actual, what's called a corner.
Is it an absolute value?
Yeah, it is. Good. We're going to get to that this year for sure. It's an absolute value function. You don't have to know that for right now, okay? But keep that shape. A V shape on a graph is an absolute value graph, actually. Okay, but again, doesn't matter for now. The idea that's important right now is this. It's decreasing and then it's increasing. So right away, it can't be a linear function or it can't be a line. Clear? All right. Georgia, part C, please. Part C.
Okay, so part C, so on the x side is +1, +2, and +4. And so the difference between that, it's kind of multiplied by 2 each time. And then on the other side, on the y side, it's +2, +4, and +8.
So even though the x's, the increments were doubling, what did you notice about the y increments? They were also
They were also doubling to, I guess, divide by 2. I divided the y by x, so yeah, 2x.
yeah. So no, just 2, not 2x, it's 2.
Yeah.
So what we'll see here is that the increment in the y for the first one. Look at only the first two coordinates, please. Look at 0, 1, and 1, 3. Okay, just look at those. Don't look at anything else. Y goes up by, fill in the blank, please. Y goes up by 2. X goes up by. So it's a change in y of 2, a change in x of 1. So between the first 2 points, the slope is 2/1. Right? Now look at the middle points. That goes up by 4, and that goes up by 2. So the slope between the middle points is 4/2. What's the slope between the last 2 points? What does this go up by?
8.
And this goes up by? 4. So it's 8/4. Aren't those all the same fraction, really? Okay, so the slope is indeed 2. Okay, again, look at your changes between any given point. This is 2/1, this is 4/2, this is 8/4. Those deltas, those changes, are all going to be consistent. Okay? Is that clear? I know the last one was a little tougher than the first one. Okay, it wasn't as obvious. Let's take a look at the next. Example 4. What do you know about the values of a and b if the line ax plus by equals c has the property described? What do you know about the line? All right, well, let's say the line is horizontal. The line is horizontal. What is my slope when the line is in standard form again? Slope equals? What was our theorem from before? Slope equals? Yeah, and I'm going to say, and this is going to sound weird, but I'm going to put the negative sign out front now instead of next to the A. I'm going to write it like this. And there will be a reason for that, trust me. Okay, so let's say the slope is the opposite of A/b. Negative A/b, or the opposite of A/b. If a line is horizontal, what slope is it?
0.
So if you get 0 as a slope, what does that mean about the fraction?
Then A equals 0.
A must be 0. To get 0 as a fraction, we're going to notice that the numerator has to be 0. 0 divided by 5 is 0. 0 divided by 8 is 0. 0 divided by any number is 0. So to get a horizontal line where the slope you know is 0, that means that A must be 0. So for part A, the thing that we know is that the numerator, or A, must be 0. I don't care about B. I don't care about the negative sign out in front. Does that make sense so far? How about part B? And part B should come as a result of part A. Austin.
Wouldn't that be equal 0?
Very good, because a vertical line has what kind of a slope?
What doesn't change, does it?
Yeah, so we say, what is it?
An undefined slope.
Yeah, not defined slope or an undefined slope. Well, if something is undefined, it means you're dividing by 0. That's how you get an undefined answer, when you divide by 0. So as Austin said, for part B, for it to be undefined, B has to be 0. The denominator has to be 0 for part B. Okay, again, for an undefined slope or a vertical line, that means that you're dividing by 0. So this must be 0 for this to make sense. How about part C? The line rises, draw a picture, it rises from left to right. What kind of a slope is this, Chris? What kind of a slope? It's a positive slope. It's a positive slope. This is a little trickier though. Okay, m is positive, or you could simply say m is greater than 0. If it's a positive slope, what do I know?
B has to be a positive number.
B has to be a positive number. Why would B have to be a positive number?
Because of the y axis and your vertical change.
Okay, you're on the right track, but you're missing one part. Can somebody help me out here? Would A have to be bigger than B? The idea is okay, but not necessarily true. You could have A less than B and still have a positive slope, which would just be a fraction, right?
A would have to be negative.
A could be negative, B could be positive, like you're saying, but there's something that you're missing here. When it's a positive slope, it means that your division of A over B, well, in this case, negative A over B has to, in the end, be positive, right? Pick a number for A. Any number for A. Pick a number. What is it?
7.
7. Everybody put 7 in for A right now. So write negative 7 over question mark. If A is 7, so let's, again, we're coming up with a scenario. We're saying, let A equal 7. I'll put it on the side over here. Let A equal 7. Then our slope becomes negative 7 over some number. Agreed? Yes? No? So what must, as you said a minute ago, David, what must B be if A is positive? Again, A was 7, which is positive. Ignore the negative sign, because the negative sign is tacked onto the slope. When A is positive 7, what must B? What kind of a number must B be? B has to be a negative number. Because what's a negative over a negative? It's a positive. And we said for part C, the line rises, right? That's a positive slope. So when A is positive, B had to be negative. But now pick a number for A that's negative. Erase A and pick a number that's negative. Let's say negative 8. So this becomes negative 8. What's a negative negative, everybody? So for this slope to remain positive, now B would have to be, because you'd have positive over a positive, right? Negative 8 is a positive 8 over a positive. So what you're noticing is that when A is negative, B had to be positive. But when A was positive, B had to be negative. So what conclusion can we draw from part C? What statement can we make that summarizes what I just said there? Again, when A was positive, B needed to be negative. But when A was negative, B needed to be positive. So what do we know about A and B?
A has to be the opposite. Not like the opposite of.
A and B have to have opposite signs. There it is. For part C, the actual answer is that A and B just have to have opposite signs. If A and B ever have opposite signs, your slope is going to be positive. Because you're going to have opposite signs, which creates a negative quotient. But there's a negative out in front already. Okay? So whenever A and B are opposite signs, you get a negative answer when you divide them, but the negative out in front makes that a positive answer for a slope. What would you expect for part D? Use your deductive reasoning. You have part C, use that to help you with part D here, Francis. Yeah. For part D, it says the line falls, so we want a negative slope. To have a negative slope, A and B have to have the same sign. Because if A and B have the same sign, you get a positive quotient right here. You get a positive quotient right here. But then you have to tack on this negative. So in the end, A and B have to have the same sign for part D. Okay? A little bit tricky. Okay? I explained it a little slower in the video. If you're having a little trouble, please take a look at that one. Okay? I'm going to go on to the next one for the sake of time for right now. But again, this idea, A and B should have been pretty easy. C and D are a little trickier. Okay, example 5. Graph a line that has a slope of negative 2/3 and goes through the point negative 2, 4. Please use your graph paper. And I did the same, okay? I actually went ahead and got some graph paper also. Where I saved one of those images so I can do this in class now. Because my graph looked terrible the other day and I felt embarrassed. So let's take a look. If I know I'm going to the point negative 2, 4, that's right up here, I can increment my axes by 1s. Let's put a label on each of them by 1s. And label our x and label our y. Please always label those components. Please, please, please. You will lose points on a test if you don't label your axes. You need to know what they are. So I go negative 2, 4, that's right here. I go ahead and I put a point there. Now, the slope is negative 2/3. So this line is going to rise or fall? Fall, because it's negative. So I know it's going to go down already. I already know that this thing is going to go down like that. So I can already see that I'm going to have some sort of a decreasing line. What does negative 2/3 really mean? Well, let's take a look. This is your delta y and this is your delta x. So that means I can go down y 2. So take a look. I'm going to show it. Go down 2 in the y direction. That's where your point is. But then go positive 3 in the x. So there is my next coordinate right there. That's what a negative 2/3 means. But you might say, hey, Mr. Howell, negative 2/3 could also be written like this. Agreed? So then I would have a positive change in y, but a negative change in x. Well, let's take a look at what that looks like. Go up 2 for y. Up 1, up 2, and go negative for the x. There's another point right there. Does it matter which way I did this? How come? Why doesn't it matter? A lot of you said, no, it doesn't matter. Why not, Chris? It's the same line either way. All you need are 2 points. Remember from our intercepts? All you need are 2 points. So you can pick these two, the red and the blue, or pick the red and the black, or pick the black and the blue points that you just created. Either way, it doesn't matter. The idea is that you do have a line that goes through these 3 points. Okay? Please use a straight edge. I'm just using it quickly. I know mine's not perfect. Please try and use a straight edge. And clearly it's a negative slope because the line falls. The line falls. If your line rose, you must have made a mistake, right? So use common sense to answer these questions also. The last one I want to do, you have about 2 minutes. Please take out your calculator real quick. As soon as it's out, look up. As soon as your calculator is out, please look up. The problem says the following. On a calculator plot, on your calculator, plot the family of lines y equals ax, where a could be any of these possible values. So what I want you to do is this. In y1, plot 1/2 x. In y2, plot negative 1/2 x. Graph them together. Then on y3, you can graph these together by themselves, or together, and then go on to y3. Then in y3, graph y equals 1x and negative 1x in y4. In y5, graph 2x. In y6, graph negative 2x. In y7, graph 4x. In y8, graph negative 4x. And I want you to end up graphing all of these, but I want you to see the correlation. Okay? And you'll notice that as the slope changes, you're going to see the steepness of the line change. And as the slope becomes negative, you'll see the line be in the negative or falling direction.
Should we do this on one?
Okay? So y1 and y2 you can graph, and then hit graph and take a look at them. Okay? y1 and y2 you can plug in first and then graph them. Remember with a fraction you use parentheses. Okay, so make sure you put a parenthesis around your fraction. Okay, graph them together and take a look. You do have homework tonight. Okay, yeah, you're going to see like, it looks like a star almost. A lot of them, and what I want you to do is try and graph them in groups. Graph y1 and y2 first. Then graph y3 and y4 together. And mix around with these and see what happens. Okay, please graph them in little groups and you'll notice correlations there. Okay, take a look at your homework. You'll see it tonight. There's not a lot. It looks like a lot, but they're not that tough.